Inmarsat is a mobile satellite operator. The company's been in business for actually more than 30 years. Its history is actually based in the maritime industry, originally set up to provide safety at sea communications. Over the past 30 years, though, the company has evolved and developed a strong portfolio of both land and aeronautical services as well. We're here today to talk about what we're doing in the utility sector in particular. We've worked with utilities for quite a long time. Traditionally providing solutions for mobile workforce, for disaster recovery, business continuity. More recently, with the advent of smart grid and a big push into automating various layers of the grid, we've also started to move into providing a connectivity solution for things like smart metering, for distribution automation, substation connectivity, working both with utilities and some of the other vendors to utilities that are providing those platforms that rely on communications to operate. Within a utilities operating area, they're going to have infrastructure located in a number of areas. I mean, some are going to be in fairly urban areas where you're likely to have existing commercial wireless services that are going to support mobile workforce requirements. It can be anything from the requirement for service crew to be able to download a work order when they arrive on site to either do maintenance or possibly even construction on a facility. Could be time reporting when that workforce or when that crew starts work, or even reaching back to the headquarters, I guess, to get technical support from engineers, maybe new drawings or other specifications that they need to download. Within a utilities operating area, they're going to have infrastructure located in a number of areas. I mean, some are going to be in fairly urban areas where you're likely to have existing commercial wireless services that are going to support mobile workforce requirements. It can be anything from the requirement for service crew to be able to download a work order when they arrive on site to either do maintenance or possibly even construction on a facility. Could be time reporting when that workforce or when that crew starts work, or even reaching back to the headquarters, I guess, to get technical support from engineers, maybe new drawings or other specifications that they need to download in order to complete their work in the field.
So you're really improving customer service, and you're also improving the operations.
Making the utilities more efficient in their operations, eliminating downtime, really. I mean, what I understand from talking to some customers is, in the past, you might deploy a crew to a remote site, get there, find out that there's actually some anomaly to the way the infrastructure has been set up or configured that requires them to get new drawings or new specifications done by an engineer back at headquarters. Sometimes a work crew would sit idle while someone would drive back, maybe 2-3 hours, sit down, spend half a day getting a new specs worked out, and come back to that work site. The crew has effectively been idle for perhaps a day. And automating the workforce, you've got the ability to have a real-time exchange of that kind of information, keeping work crews moving while they're in the field, making the, as I said, the utilities operations more efficient, eliminating downtime. One of the first problems that we've been brought in to help address is connecting smart meters working in more remote locations. I think you've seen regulatory drivers in a number of states that have pushed utilities to try to cover 100% of their customer base with smart meters. There are a number of locations that they cannot get to with existing commercial networks that they might use to backhaul those meters, or backhaul the data off those meters in many locations. So they've looked to satellite as an alternative or as an extension of their network into more remote locations. We're effectively offering a sort of a bigger pipe backhaul off of an AMI concentrator. So as I'm sure you're familiar, you might have multiple, anything from hundreds to a few thousand meters sitting behind a single concentrator, which is connected to those meters through a local wireless network. We're essentially sitting on top of that concentrator and providing a backhaul to the utilities data center to connect those meters that are sitting remotely. I think at this early stage, it's primarily about customer service. It's giving the utility the ability to provide more accurate billing to customers, and also giving the customers the ability to view their usage in real time in order to help them manage their usage and reduce their power costs on a monthly basis. down the road, it's going to give the utilities the ability to start reaching into the consumer's household and controlling some systems in exchange for lower rates on their power. So for example, if you're a consumer and you've got a pool at home, you may want to offer the utility the ability to schedule when you cycle the pool filter in order to get a lower rate on the power that you're using at that time. So there becomes a control function in the sense that it gives the utility the ability to actually start offering you lower power rates in exchange for a certain amount of control on the systems in your home. This terminal here, this is a BGAN terminal, BGAN, Broadband Global Area Network. It is effectively two networks in one box. You've got both a circuit switch network and an IP network. On the circuit switch side, you've got a basic voice service and an SMS service. On the IP side, you have a standard IP service, which is a best effort internet connection, and a standard IP, or a streaming IP service. Streaming IP is effectively a guaranteed bit rate service designed to support applications that require a fixed throughput, something like video conferencing or video streaming. This is one of the Class 1 terminals. The Class 1 give you the highest capacity. You get the full half megabit service on the standard IP. You get up to 384 kilobits per second service guaranteed on the streaming IP. In this terminal, you've also got a Wi-Fi access point, or you've got the ability to plug in Ethernet or USB. So you've got this on the large scale. We've got what are called Class 2 and Class 3 terminals as well. Effectively slightly smaller capacity, designed more for the single user. A terminal like this is designed more for enterprise use or a multi-user environment for remote office or some other multi-user environment. All of our terminals have been tested for extreme weather conditions. A terminal like this can actually be mounted outside on a simple pole mount with a cable dropped into a building if it's in a fixed location. There's nothing needed to protect it, although for most of the utility installations, it is being deployed inside an enclosure. The enclosure just ensures a longer life on the terminal, although we've got terminals that have been deployed for 5-6 years, really since the service was launched. They're still in service. Why am I doing what I'm doing? I think it's very interesting. I mean, it's probably it's a challenge of solving a problem. I mean, the problem being a lack of communications in some geographies, not just in North America, but around the world. Inmarsat is a global company. Our satellite network provides service anywhere on the surface of the Earth. If we're looking at the utility sector, I mean, in North America, there's a great opportunity for us because there are a number of areas where terrestrial networks do not reach. If we start looking at markets in Latin America and Asia, you see an even greater opportunity because while you've got terrestrial networks in the populated areas, if you get to more remote locations, you've got a lot of infrastructure that's not reachable with existing technology. So I think it's everything from solving a problem for utility to there's an exciting element, I guess, of being able to provide a cutting edge technology to anyone, anywhere.